Today's lesson is on compound inequalities. And a compound inequality is when, in one example, we have two inequalities at the same time, and they're joined together by the word and or the word or. I would say that's a pretty crucial conjunction. Here's our first example in which we have two inequalities. They're both facing the same way, they're both less than, and our variable is in the middle. So we're saying that 2x minus 1, this is greater than negative 3, but 2x minus 1 is less than 7. So it's in between negative 3 and 7. And we want to solve for x, which means x is all by itself in the middle between two inequalities. So just like when I'm solving regular inequalities or equations, I draw my line at my inequality sign, but this time I have two of them. So we always want to undo the operations in the middle. So I'm going to add 1 here because I want to get rid of the 1. But whatever you do to one side, you have to do to all sides. So we have to add 1 in 3 different locations. Here it crosses out, and we're left with 2x in the middle, which is less than 7 plus 1 is 8, and then negative 3 plus 1 is negative 2. And then last step, I want to divide by 2 to get x by itself, which means I have to divide by 2 everywhere. So I have x is in between, negative 2 divided by 2 is negative 1, and 8 divided by 2 is 4. So x is greater than negative 1, but it is less than 4. We now need to graph this inequality, so I made a number line that has negative 1 and 4 on it. And both of these inequality signs mean I have open circles at negative 1 and at 4, and then x represents all numbers in between negative 1 and 4. Here's another example where we have to solve and graph. This one's set up a little bit differently. Instead of putting them all together in one expression, they're separated by the word and. But all it means is that we have two inequalities that we're going to solve, and then we can put them together. So, for the first one, all we have to do is divide both sides by 3. So x is greater than or equal to negative 2. And on this side, divide both sides by 3. So x is less than 5. So x is greater than negative 2 and x is less than 5. We can rewrite this. So x is in the middle, x is less than 5, but then if we flip this part, x is greater than or equal to negative 2. So x is in between negative 2 and 5. So then if we graph this, we have negative 2 and 5. Let's put circles at negative 2 and 5, close circle at negative 2, open circle at 5, and then we shade in between. This time we have a sentence here that I'm going to rewrite as an inequality. It's an and statement. It says all real numbers that are at least negative 2. So if it's at least negative 2, that means greater than or equal to negative 2. And at most 4. So x is less than or equal to 4. And then if you write it together with x in the middle, x is less than or equal to 4, and x is greater than or equal to negative 2. So it's in between negative 2 and 4. And in this example, you start with a graph, and we once again are just going to write the inequality. So this is representing all real numbers in between negative 2 and 3. And it includes the number 3 but does not include the number -2. So when you rewrite your inequality, x is less than or equal to 3, but x is greater than -2. So this would include 3, but not include -2. Here are two more examples where you have to solve the compound inequality involving the idea of an AND statement. So if you want, you can try these two on your own and then check your answer. For this example, I first subtract -7 on all sides and then divide all sides by -3. Because I'm dividing all sides by a negative, I have to flip the sign. So after we flip our signs, we have 3 is greater than x, which is greater than 1, but the standard way to write it is to always write your final answer with less than signs. So that means it's like you're flipping this entire inequality. So we're going to have 1 here and 3 here. Now solve the second one. And you should get that x is in between 1 and 7. Last two examples involving AND, I want you to try these on your own. All real numbers that are between -4 and 6, and then here you have a graph, and I want you to write the inequality for both of them. Because it says between, I'm not including -4 or 6, so I have less than signs. But in this case, because I have closed circles, I do include 8 and 12 with less than or equal to signs. Okay, we're going to do the same type of thing, except now we're involving OR statements. We're going to solve, and we will graph, and then we will write inequalities from graphs. So 4v plus 3 is less than -5, or -2v plus 7 is less than 1. All this is you can just think of it as two separate inequalities that we have to solve, both of them. So the first step, subtract 3 on both sides. So 4v is less than -8, and then divide by 4. So v is less than -2. Or, let's solve the second one. Subtract 7 on both sides. So -2v is less than -6. And now divide both sides by -2. Because we divide by a negative, we have to flip the sign. So v is now greater than a +3. So either v is less than -2 or v is greater than 3. Now let's look at how we would graph this. If we have -2 and then we have a +3. Circles at -2 and 3 both open. V is less than -2, so we're shading out to the left. And then v is greater than 3, so we're shading out to the right. So either it's less than -2 or it's greater than 3. Now here's a sentence that I want you to write the inequality. All real numbers that are less than -3 or greater than 7. So x is less than -3 or x is greater than 7. And on a graph, if you have -3 and 7, that means that it's less than -3 or it's greater than 7. They're moving away from each other. Now here we have a graph. I want you to write the inequality. So for this half of the inequality, this says that x is less than or equal to, because of the closed circle, -9, or x is, here it's greater than 0. And that is it. Here are 3 examples involving OR statements. So I want you to pause the video and write all of them down and see if you can try them on your own, and then check your answer. For the first one, you should get that x is less than or equal to 2 or x is greater than or equal to 3. For the second one, x is less than 12 or x is greater than 60. And for the last one, x is less than -3 or x is greater than 5. So that is your full lesson on compound inequalities involving and or statements. Pretty easy, so good luck with the lesson.